Okay, we're going to talk about how to do our motor controls input and load test sheet. Okay, so I'm going to get you started on it. Now, you want your ohm meter, and we're not going to have it plugged in, okay? Because when you're using a multimeter, it's the only function on your multimeter that supplies power to the circuit. So all your circuits have to be dead every time you use an ohm meter, okay? So make sure that you're unplugged and you don't have any wiring. You haven't added any wiring. So we're going to check all the individual input devices, the switches, the push button switches, the selector switches. We're going to check the lights and the relays. And this is going to help you understand the individual parts. It's so critical to be a good motor control troubleshooter, to understand the individual parts, to see how they go together and the functions. So let's turn it on ohms, okay? And I always short the leads to make sure that I've got good leads. I do, okay? Now on a button, you're gonna see a block, and that block, if it's the same size as the full back of the button, there's two contacts there. One says NO for normally open, one says NC for normally closed. That is just like they come out of the box without your finger on the button. That's what that refers to. All motor control prints are drawn in the de-energized state. They're referred to in the de-energized state. So a push button without your finger on there would be the de-energized state. A relay would be without power on the coil. That's the way they're drawn, okay? So if I look here, this side of this switch says NO for normally open. So a normally open switch should be infinity or OL when I put my meter on it. So let's see, okay? It is OL. Now it's a yellow push button. So when I press it, okay, it goes down to 0.3 ohms. Now 0.3 ohms is good, 0.4, 0.5. What you don't want to see is 15 or 20 or 30 or 100 ohms. That's a bad contact, okay? So you always have to take your meter lead lead resistance into consideration. We've got 0.2 ohms, excuse me, 0.2 ohms on our meter leads. So if we read 0.2, it's essentially 0. So if we get back here on the normally open one, the de-energized state, it goes down to 0.2, so that's 0 for us. That's meter lead resistance. Now, if we get on the NC, which is normally closed, we should read 0.2. And if I can get it on there, you may have to tighten the screws some to get a good reading, okay? So let's do that. Sometimes if the screws are loose, you'll have resistance in the threads. So I'm just tightening them up. Now they're not lug nuts on F350, okay? Just barely tighten them up, just snug them up, okay? And we see 0.2 ohms on that. Now, that is normally closed without touching the button. Now, 0.2 ohms, if I press the button, it should go to OL. And it does, it goes to OL. When I release it, it goes back to 0.2. So that's a good contact. There you go. So, that's how you check a push button. Now, a selector switch, I've got on that load test sheet whenever the button's left, center, or right. We're referring to the top of the button, the top of the selector switch. When the top of it is turned to the left, that's the left position. When the top of the button is in the center, that's center. And when the top of the button is to the right, that's the right position. looking at it from the front of the switch, okay? So I've got on there to check both contacts in the center position, both contacts in the left position, both contacts in the center, and both contacts on the right, okay? That's that. Now, on your lights, you have 4 different color lights: green, amber. We normally call it amber instead of yellow. I don't know why, we just do. Green, amber, red, and blue. And these are the 2 connections right through the back, okay? So you can put your meter on there and it should be in the megohms, okay? Or you can go through the sides if you can't get a good connection there. Now I've got 8.32 megohms, okay? These are LED lights. So they're gonna read, excuse me, they're gonna read in megohms. LED lights have to have a driver, and that's what limits the current through an LED. All your bulbs in your house will have drivers. Your Christmas tree lights will have drivers. Street lights, if they're LED, have drivers, and they're all different. It depends on the amount of current that LED bulb needs. So all these colors will be different. At least they are so far on all the trainers I've checked. So you just get across there. They're 24 volt bulbs. Everything on here is 24 volts. So check all 4 of your bulbs. Check your selector switches. Now when you get to your relays, everything's falling apart. Almost like Friday, but it's not. Okay, this relay here, these 2 little, you can see these pins. These 2 pins here, that's your coil, okay? That will be reading somewhere around 600 to 700 ohms, probably around 630 ohms. But I want you to check both yours because they'll be a little different. They're all a little different. Sometimes they'll be the same, and sometimes, you know, it depends on the manufacturing process. But you want to know how many ohms yours is so that you'll know what you're hunting whenever you start troubleshooting. We're going to start troubleshooting. Now, if you've ever stood at a panel with a meter, or if you've ever been over a project, okay, in the lab, and you didn't know what to do with your meter, okay, I have found that it comes down to a couple of things. First thing is, can you read a print? If you have trouble reading a print, the odds are you're never going to be a good troubleshooter until you put the work in to learn to read a print. Nobody's born knowing how to read a print. You got to go through the blood, sweat, and tears of learning to read a print. But it's impossible, in my opinion, it's impossible to learn to read a print if you don't understand the individual pieces. So if you don't understand how a switch works, it's going to be tough. If you don't understand how your bulb works, it's going to be tough. If you don't understand how a relay works, you know, you're probably not going to get there. So that's why we're concentrating on the individual parts right now, because we're going to start putting them together. And we're going to learn to read prints. We're going to get that skill set down. And then once we understand the individual pieces, you can read some really complex prints pretty quick. But a lot of people just won't stick with it. You know, you got to get over that hump to where you want to print. If you're there now, great. But more than likely, at least some of you guys don't want to use a print. I can't count the times I've seen guys move both meter leads for 8 hours. And you ask them what they got, and they can't tell you what's wrong. Well, you know what? If you can read a print after 8 hours of using your meter, you ought to be able to tell at least some things that's right. You might not have found a problem on a big old machine, but you ought to be able to tell me a few things you've got that you have ruled out that's not the problem, you know? But these are people that can't read prints, and they're guessing, you know? We want to take the guesswork out of it. We want to understand the individual pieces, understand the prints, and if you stick with me, I promise you we'll get there. If you put in the work, we'll get there. By the end of the semester, you'll want a print and you'll want a meter, okay? So, there is a spec sheet on Blackboard. These pins back here, it's called the pinout, P-I-N-O-U-T. Spec sheets are also called cut sheets. Now, we've got Google in our pocket with our phones, right? Better than it ever was the whole time I was out there. But if you look on this relay, it has the pinout printed on it. But if you print out that cut sheet that I've got loaded on Blackboard under course content for relays, for the take-home trainer relays, it'll show you what all these pins are, okay? And you have two, what we call Form C contacts. A Form C contact has one common, and then it has another connection for normally closed and another connection for normally open. I personally love Form C contacts because if you need a normally open, you got it. If you need a normally closed, you got it. Whereas other relays who have standard contacts may have two normally opens, two normally closed, one normally open and one normally closed, but you normally can't change them. So with a Form C contact, it doesn't matter which one you want, normally open, normally closed, you got it. Now, I'll cover this more on a Form C contact in a future video. But right now, you need to print out the cut sheet and make this make sense. Look at the pins, make it make sense, okay? Now, this little green button, if you look at the side of the relay, okay? Side of the relay, if you press that green button, you can make those contacts move just like the coil. That's a manual override. So I can take and press that here, and that's the same thing as the coil getting voltage to change those contacts. So it's a great troubleshooting tool to have, but you gotta be very careful with it because when you press that, whatever those contacts are hooked to, you're getting ready to make something move. So you gotta be very careful and understand what you're doing when you're pressing the override. Now when you're ohming out a circuit or ohming out the contacts, it's not a problem, but manual override. Okay, so I hope this helps. Fill out that sheet. If you have any questions, email me, marty.higdon@kctcs.edu, and we'll work through this and we'll get started on some labs here in the very near future. Take care and stay well.